I love these software development, and they keep updating and to make you feel that's totally foreign. Well, first of all, I want to thank very much to Dr. Van Braun and the IFPRI for this opportunity to come to share my perspective, what I know about the nanotechnology applications in agricultural food. And I'm very much looking for this opportunity to interact with the audience, and I recognize some of you that through our past interaction, and I have spent a fair amount of your time and study nanotechnology relevant to food and agriculture issues. And others will be new friends, and looking for this opportunity to interact, exchange through these exercises. And it is wonderful to speak after Dr. Michael Rocco. He has set a wonderful platform and get away many tough challenges to explain what nanotechnology is really about, what is the status overall. So this is wonderful. The other thing I want to thank Mike is that he's a tremendous visionary individual, and he really sees the nanoscale science will generate a significant impact in all aspects of science and technology. He encouraged other departments and agencies, other scientific disciplines to think about advancing the nanoscale, the science in nanoscale, and then draw their application to the field relevant to their particular field. And Michael showed a picture of USDA CSIS-led the strategic planning workshop in 2002. Michael was very strong support from that moment, and he was a keynote speaker at that event. So since then, we maintained continual interaction and seeking advices from Michael. Even today, we talk about possible summit down the road, and Michael is on the steering committee. And so we thank him very much to Michael for sharing his vision to help us. The assignment today I have is to talk about the nanotechnology application in agriculture and food production, and that's what I stated in the email. And you notice that I dropped the production to recognize the production is only part of agriculture and food. There are a lot of things happening after farm gate. And so I purposely leave that way, and just to bring attention to the audience, the tremendous needs across the entire spectrum of agriculture and food production and the processing to the consumption, and all the way linked to the individual health and the industry materials. So that is the intention. However, given that 15 minutes that I'm allowed, and it's not possible to explain all the possible applications, ideas being thought by people. So this is really just give us some example of the certain applications that I've seen. Many focus in USDA, CSIS support projects, and as examples. All right. I'd like to start off with a very bigger picture. Dr. Richard Smalley wants to show this slides, and the top 10 challenges to humanity within the next 50 years as the population is expected to increase to about $10 million. As you can see, many of these are relevant or related to agriculture and food. For instance, number 3, food. It's squarely fallen on the shoulder of agriculture and the food industry, while others, agriculture is part of that challenge and also could be part of a solution to many of those. The agriculture in U.S. has been doing a fantastic job, and then that same experience perhaps shared by many other countries, particularly in the developed country. Look at the investment in the agriculture, the inputs over the last 50 years. The EIS indicated it's pretty much fallen on a flat line. However, the output and the productivity increased tremendously over the last 50 years. When we talk about the sustainability in the next 50 years, next 100 years, can we maintain this trend? And then the people working in the research field think science could provide some of those solutions, while other fields of science, including the policy, could also work together and then develop a solution and a strategy for that. Today, I want to focus on the nanotechnology, what nanotechnology can do to help to maintain that trend and maintain the sustainability. I feel that the USDA founding father has tremendous wisdom early on, and they recognize the agriculture is not only the source of providing food, feed, and then the fiber, but also it's a tremendous source. It's a foundation of a manufacturing and a commerce. And so I think that has tremendous implication, especially today, when we talk about the limited resources, particularly natural resources, especially the non-renewable resources, and then agriculture will play a more and more important role in the national economy. CSIS mission is, CSIS, by the way, is one of the key research agency of USDA, and we conduct extramural research through the collaboration with land-grant universities, other research entity. We also carry out higher education for agriculture and food, and we also have a tremendous infrastructure in extension reaching out the rural community. And the CSIS mission is to advance knowledge for agriculture in a very broad sense of agriculture, the environmental, human health and well-being, that's through the food, and rural community well-being. All these are intertwined as very important. It is a tremendous foundation for the national economy and many other things. As I said, I will show you a few examples in the broad areas in a plant production system, in the animal production system, food safety and agricultural biosecurity area, food quality and the nutritional value to improve human health, and then perhaps the environmental footprint and the natural resources if there's any time, and certainly there are more other applications. So first, let's take a look at a plant production system. Plant production is a very complicated system. Integrate the resources from soil, water, and agricultural fertilizers and pesticides, and a tremendous production system. And there are many challenges facing in this system. One of the things is plant diseases. The example here show is the microbial could potentially get into the plant system, and then the multiplying clog system actually choke the plant from picking up a nutrient. In the past, research is limited because if you take a plant sample at a moment, it only gives you a temporal snapshot of that problem that limits the understanding how the microbial gets in the system, how they attach to the surface, how they multiply, and etc. So, Dr. Harvey Hawk from Cornell University, and using one of the NSF support National Nanotechnology infrastructure, and using this fabrication capability to actually mimic the plant xylem and water conductor vessel, and then to look at the surface characteristics, chemical characteristics, and topographical changes within that system, and to actually simulate fluid flow within the system, and then use that to continuously monitoring the bacterial growth in the system. So that is one example of a nanoscale science help us to effectively reveal the plant diseases of interest. And animal production also facing many challenges as well, and animal reproduction, for instance, animal health, animal nutrient uptake. This is in the area, one of the areas that I show here is called zoonotic disease. That disease can infest the animals as well as human, and so it's a double hit on the society. We have supported several projects looking at a particular zoonotic disease called Meckel disease. And then the problem here is the protein will change its conformation. So that gives us a tremendous challenge to chemical analysis because the amino acid sequence and chemical composition is the same between this so-called deformed tertiary structure of a protein versus a normal protein. So we found 4 projects and tried to look at a different nanotechnology platform to develop an effective detection method. One of those is called molecular imprinting. The idea is like a blind field element. You look at the conformation of this deformed protein structure and feeding different parts and integrate that information, tell, haha, this is the bad guy or this is the wrong one, and versus a good one. One of the implications of this particular technology, if successful, is that they can serve as a chaperone and then to change the wrong conformation to the correct one, therefore cure that disease. And that has tremendous implication in terms of the animal disease curing process. And the last example is using so-called microcantilever technology. Microcantilever has capability to push the detection limit down to the single molecule level. And so the research is pushing in that direction. This particular project has down to the level of 2 nanogram per ml sample sensitivity, and the research is continue going. The idea is that to develop a handheld device that you can detect, take a cow's blood sample, and then you can do that easily at the farm level, and then you can detect all the cows as you need instead of a current practice is a post-mortem, take a larger quantity sample of a brain and take a long time for that. And this is also, of course, solve the problem of the needing of a larger investment in terms of the equipment for the single testing lab, a multi-million-dollar equipment that are needed to do this job. So it's very exciting. This is an example, a different example, and has a very versatile applications. Dr. Dan Lu from Cornell University called it the nucleic acid engineering. It actually taking small piece of a DNA segment, use that not as a genetic material, rather using as a generic construction material. And this is at a nano size. As many of you know, that the DNA has 2.5 nanometer diameter. So the idea is that building this Y-shaped structure, and you can do the multiple generation, multiple structure, and by putting different dial on a very simple structure, and you generate optically recognize distinctly different particles. And with this open end, if it's using for the sensor purpose, and then you can use that detect multiple targets simultaneously. Let me just get down to the bottom of this slide. And what this one shows, a test of 3 different biosecurity target, anthrax, Ebola, and SARS. And as you can see on the bottom right hand, and it shows very clear 3 linear relationship there, and showing the efficacy of this test. And detection limit is down 10 to the minus 18 more, and detection speed is extremely fast. Okay. We have many other projects that support the sensor for the food safety and the agricultural biosecurity detections. And there is another part of the safety requirements, that is intervention technology. All right? This is an example showing that using polystyrene nanoparticles to competitively remove a pathogen from poultry guts before the slaughtering, so that you minimize the pathogen bacterial load, and therefore enhance the poultry meat safety, because the experience tells us that the post-slaughtering cross-contamination is a main problem caused food safety issue with the poultry meat. And it's a quite an effective project. And the approach has been demonstrated quite effective. And most exciting is that the nanoparticle has a sticky finger that is tunable, and you can detect various different targets based on the little finger to grab the bacteria of interest. Within the NII scope, we talk about the responsible development technology. When we dispose or when we disperse this technology, when we deploy this technology, feed the cows or feed the chickens and turkeys with this beads, is any safety concern? Is any safety concern to the operator who mixed this nanoparticles with the feeds? This particular project support a variety of toxicity study, and as you can see, the list is quite comprehensive through the skin, through the eye contact, inhalation, and ingestion. And the results come out, basically this particular particle does not generate any adverse effect. And so that is very encouraging. I want to turn our attention around a little bit in terms of in food formulation, and one very exciting area is the nanoscale delivery of micronutrients. And as some of you may be very familiar, and the nanotechnology is about the capability to put a multiple function into the single particle, single device. As Michael pointed out, that there are 5 generations of these. At this stage, we are in the transition between first stage, just making passive nanoparticle delivery system, to the second generation, controlled release targeted delivery mechanism. There are a variety of functions that can be fulfilled in this system. And due to time limitation, then I will skip this busy slides. Perhaps also skip this one, is talking about various different encapsulation systems available, and that's extension of the long time study of emotion, but we get into the nanoscale. So this project has multiple applications as well. This is talk about Kongzen currently has limited value and mainly used for the animal feed. As you can see, this very unique nanostructure of Kongzen on the up left-hand corner, and could potentially lead into the production of a tubular structure as carrier, as shown in this micrograph, for the drug delivery or for micronutrient delivery. And it could possibly form a sheet layer by layer formulation for the packaging application. They also explore the possibility that use as tissue scaffolding material, so grow the new skin, so to speak, for medical application. For the agriculture's increased value for the underutilized the agricultural material. Packaging, certainly very important to the food applications in terms of safety and quality maintenance, and a variety of projects being conducted in this area. Nanocomposite, building sensors into it. So it is a very exciting area. This is about a non-woven texture in this near nano fiber that go through the electron spin technology. And the importance here is that multiple function can be built on these fiber and carry out the various different function for the packaging and the easy detection applications. All right. Early on, when you recorded the slide, point out the 10 humanity challenges, the number one is the energy. The agriculture could potentially provide a solution to that. One of the projects that we support is taking a protein synthesis structure from a leafy vegetable, such as spinach, and isolate them, line them up, and then build it into the devices, as you can see on the up right-hand corner. And that shows that the system actually works when you turn the lights on and off and generate the electricity. And so more important here is that this is a very effective project on the up left-hand corner. Within the time frame, a little bit over a year, it shows the efficacy of that conversion being improved by 5 or 6 orders of a magnitude. That's significant improvement. So the statement of the spinach will not only help you build your body, it could also power your laptop and recharge your cell phone. It's not too far in the future. CSIES has an outreach activity, and we made a DVD highlight 4 research projects that is available online, and I have a postcard outside. You're welcome to take it, and it's the 30 minutes program on talk about value-added use of agricultural material, sensor and detection, new uses of nanobiological material, and also the environmental monitoring for the non-point pollution, which is a very, very critical issue in the agricultural production. Well, no matter how much resource you have, let alone that we really don't have a whole lot of resources, even within the NNI activity, and the agricultural and food-related investment is rather limited. So the international collaboration is tremendously important to help accelerate the pace development in this area. This is a list of multiple countries that I have a contact with that has a various different effective programs and activities. One of the areas that Dr. Rocco pointed out in the area of the safety and the risk assessment. This is the concern to everybody who will use nanotechnology, who will interact with the nanoparticles. Therefore, this is the front that is most could be most effective area to have international collaboration. Well, the last slide I frequently use to share with the people talking about the importance of education. When scale of science move down to its ladder, and it could generate a tremendous implication and impact. For instance, the discovery of a bacteria, and that's the fundamental aspect of the study in terms of food quality, biological production, biotechnology, and that's discovered more than 100 years ago. And when the discovery of DNA, that lays the foundation of a biotechnology still in the heat of its time, and the nanotechnology certainly will have a significant impact in the future. So when I tell my colleagues in the university, or when I provide advice to young fellows, I say, go nano, go nano. All right. This is just show the web page. You can get the report that we done. We did it in 2002, and it's still of some significance, although I think that perhaps needed to be updated because of the advance in the field is so rapid. So, and I am planning in the different forms of working in that. Thank you very much for your attention.